generally, and more specifically about this new tool, Retriever, that we're going to be launching in January. So I'm really excited. With me are E and Drew, the two other members of the core team. We're all software engineers, so if we flub and don't know a firm or don't know a project, please forgive us. But we're very excited to be working in the AEC space. Drew and I were at Flux for a while together, and I see a bunch of the teams here. Hi, guys. And E joined us from Onshape out in Boston. And we're hiring. It comes with an asterisk. So if you know any really shit-hot computational designers, we would love to talk to them. Yeah, so lastly, happy holidays. We're all going to head to Louis after this. It's at 55 Stevenson Street. I don't know if there will be a partially dissected whale, but there will probably be a couple of drinks if anyone would like to join. So yeah, Join is developing tools that deliver a new standard of accessible productivity. So we think that there's an opportunity out there to deliver tools that leverage automation and computational design in a way that allows people to better quantify cost and performance earlier in the design phase, automate away a lot of sort of the most tedious parts of the design process, examine more scenarios, and eventually improve the built environment. So we're really excited to be doing that. We've got a bunch of research going on under the hood that I can tab through. We've been working primarily in Rhino. We've been developing tools focused on the facade. So these are tools that help with system selection and searching, that help with things like checking different design rules. So once a system has been selected, we're able to evaluate different rules over it, wind load, dead load, these sorts of characteristics. The system that we've built, we talked about AI in our website, and I know a few people have brought this up. The Join is very intelligent about the products that are brought into it, and so it's able to resolve a lot of issues that might come up in the design process without having to resort to parsing the product PDF and spending a lot of time on the phone. Yeah, so there's that, and and we're also able to help with detail generation. So we can, if this GIF actually plays, pull up all these details, and you can see we can generate the whole facade, and we can do it at a very fine level of detail, supporting a lot of workflows downstream of this. And if we zoom in, we should see this curtain wall that's been designed. We've got all the mullions in there. We've got the anchors. We've got the concrete, this sort of thing. But that's not what we're here to talk about. We're really excited about this stuff. If you guys want to know more about it, sign up on our website or shoot us an email or whatever, and we'd be happy to talk more. Today, we're here to introduce Retriever. Retriever is a tool for Revit and a tool for Dynamo. And it's a tool that supports fast and flexible queries of the Revit model. So when you need to isolate parts of the model, different elements, or different properties of those elements, Retriever comes in and makes that more performant and very flexible. So that's all the slides. Like from here on in, we're going to be staring at Revit. The first example I'm going to pull up is a very basic one. We're going to launch Revit Load. And you guys can see why we're worried about performance, right? Yeah, so we've got Revit here. We got this very simple piece of sample data here. And over here is Retriever. And so Retriever is a tool that allows you to evaluate queries on the Revit model. Has anyone here used SQL, the database query language? Yeah, great. So this tool exposes a query language like SQL, but for Revit. So what we can do is I'm just going to pull up a sample query here. This is a really simple one. I didn't pull up here. I could create it. So the query that I'm going to write here is just going to select all of the elements that are walls. And I'm going to run it. Okay. And we see that Revit selects the selects all the elements that met this criteria, and also prints out some information here in this dialog. So that's sort of the key workflow here. You have a query, You either pull it from an example or write it yourself. You pass it into Revit. Very quickly, you get the results back, whether it's the elements or properties extracted from those elements. Okay, let's do something a little more interesting, just a little. So how many people have ever had a mismatched fire rating on a door and a wall that hosts it? Yeah, right? No, never, never. So this is something we hear from people working with Revit, especially in the QA and QC steps, is the need to make sure that all your doors match your walls, and going through and checking it is this tedious process. If you know Dynamo, then you're in good shape and you can do this. If you're not so lucky, it's a very slow process. So what we have here is this sample query that can select all of the doors that have a fire rating that doesn't match the wall's fire rating. Okay, and great. So there's some numbers here and some stuff's been selected, but I don't know if I believe you. So what we can do is we can also extract the actual fire ratings. So I'm going to modify the query here and run it with these new things. And we're able to pull out the fire ratings for the door and for the wall and see, oh yeah, they are actually mismatched. And if there were more of these and I needed to pass this report on to someone, I can pull up a spreadsheet, and I can paste this in the spreadsheet somewhere. Oh. Copy. There we go. I can paste this into the spreadsheet and include this in some sort of report handed off to some downstream consumer of this data. Yeah, so that's a very simple sample query, and now we're going to unpack it and take a look at what it looks like under the hood. And I'm going to try to save us some time on the next example by preloading it. Yeah, so let's look at that query we saw. Over here on the left, we have the query where we're selecting elements where the parameters don't match. Over here on the right, we have a kind of garbled English translation of that query, and they're pretty close, right? So here we're trying to select elements where the element's category is a door, it has a host wall, and the fire rating parameter, extracted here, and the door and the wall fire rating parameter aren't equal. So this is where query languages are really powerful. They encapsulate only a small part of the sort of abstraction of a full-blown programming language. So where with something like Python or something like C# or something like Dynamo, you can create this information. You can write a Dynamo script that will extract, will isolate these elements and will extract the required parameters for it. But it's a lot longer, it's more verbose, and then there are exciting things you can do with this just on the implementation side once you've wrapped up the query into this nice compact form. Yeah, so let's do another example. Who here, when working with Revit or Dynamo, has to worry about model health? All the parameters are always there all the time, right? All the data is perfectly clean. Like we've solved BIM, right? Yeah, right? Okay. So let's take a look. So here we have a sample model here. What we're going to do is go through and we're going to look for negative base offsets. So someone when modeling, put a window or a curtain wall somewhere and then dragged it down to like the story below it and didn't update the hosting level. And with this query, very simple query, just 4 lines, we're able to isolate these instances. So we can see here, we've run this and it's given us these IDs, and maybe there's a bug with selection, heaven forbid. But I swear it's isolated this element. And if we inspect it, we can see that this curtain wall, even though it's definitely on the first floor of this clinic, has a base constraint on the second floor and a negative base offset. So this is the sort of thing where it looks perfectly fine in the model, but the underlying data is actually messy, and it can lead to all sorts of troubles downstream when you're working on scheduling, or you're working on takeoffs, or you're working on passing this data to a facility manager. So you can use Retriever to isolate areas in the model where the data isn't clean or doesn't have the right properties or relationships. Yeah, so you can use it for that. And again, I'm going to pull up another example before I go forward. Let's do a building code example. Great, so let's look at building code. Hi, person wearing the Upcode shirt. So who worries about building code? IBC, right? Does this ever impact design? Do you have to worry about it when you're making decisions? Is it straightforward to keep track of all of it? Yeah, okay. Yeah, great. So we're just going to look at one tiny part of it. And the part we're going to look at is finding where safety glass is required in a model. And so there are many requirements for safety glass in the IBC. One of them has to do with pieces of glass that are near where people walk. And the basic idea here is that if you have a piece of glass that's low enough that you might walk into it, and large enough that it would be a problem if you ran into it, it should be safety glass so that when you do inevitably run into it, it doesn't shatter and cut you and like lead to sort of a terrible day. And the criteria that's laid out for this depends on a bunch of different properties, right? You can sort of get used to this, but keeping all of these, especially given that this is only one condition that would require safety glass in your head at one time, can be really tricky. So the 4 criteria that we have to look at here are the area of the piece of glass, the top height of it, the bottom height of it, and then the distance to the walking surface. Yeah, so pull up this Revit example here. And we'll see this very interesting looking arrangement of windows, right? Just like we do, a joint also does great architecture. If anybody needs like a single family home design, we'll put windows wherever we want. Oh yeah, so let's check for safety glass. So let's just scroll down, and we're going to look at this selection criteria we're writing. Here we can see how, you know, with this query language, even though it's simple, you can compose subqueries, and you can use that to build up sort of more complex things. So here we're doing a selection, and we're going to select lights of glass. And the way we're going to know that they're made of glass is that we're going to extract the material, and then we're going to see whether or not the material has glass in it. And then, given that we have this piece of glass, we only want to select it if it's near the walkway and if the dimensions match, so that it's got the right heights and the area is large enough. So you can see that we've implemented the near walkway query up here, where, you know, figuring out that something's near a walkway, we said, okay, we're going to find a find a floor that's on a level that's on the same level as a piece of glass, so it's, you know, the floor near the piece of glass. And then we're going to measure the distance and the plane of the floor, because that's what the code calls for, between the glass and the walking surface, and we're going to make sure that it's less than 3 feet. When it's less than 3 feet, then this passes. Similarly, with the dimensions match, we're going to extract these 3 parameters: the sill height, the head height, and then the area of the pane, and compare them to the values that we took from the code. So this is the sort of thing where those are the reference values from the IBC, and, you know, another problem working with the code that I'm sure you guys are familiar with is just figuring out exactly what code applies to wherever you happen to be. You know, Retriever can't help do that. Retriever's just a dog. Retriever can go find things for you really quickly, but it can't tell you, you know, what code applies to whatever municipality you're working in. But what you can do is modify these parameters if you need to. So you can adapt these queries and these rules to different situations sort of as appropriate. So we could say, you know, if we're in a different place and we needed, you know, the glass sill height to be below 2.5 feet instead of below 1.5 feet, we can just update this and we can run the query. And we can see that Retriever has gone and sniffed out each of the panes of glass that meet the requirement for safety glass in the IBC. You do this without having to like tab through it. You do this without having to set up complicated filter rules. You do this without having to like schedule it and then go through and click and check, you know, every case one at a time. Yeah. Are there any questions? You guys can interrupt me with questions anytime you'd like. Yeah. Can you build like a parameterized query and UI to make it easier for somebody that might not want to write the stuff? Yeah, that's something we're looking at. Sort of the best way to expose that. I don't know if anybody has ideas on that or sort of exactly the sort of parameters they want to inject into this. This is definitely something we're interested in. Yeah. All right. The next example. I hear everyone here might care a little bit about Dynamo. So let's do a Dynamo example. Walls and ducts. Here we go. So in this example, we're going to check for clashes. So this is sort of a classic use case of BIM is finding where somebody's put something, somebody else has put something else, and they're actually in the same place. And this is going to be a problem when you go out to construct the building. So in this case, we're going to be finding intersections between ducts and walls. Very straightforward case. And we're going to see the Dynamo interface for Retriever, which is very simple. And we're going to see the results of a performance comparison between doing this query with native Dynamo nodes and using the Retriever node. So here we have, if we zoom in, we're going to see a lot of ducts and walls. It's a very, very poor design. Every wall, it turns out, intersects with a duct. That's what we got. And And actually, I'm going to delete a bunch of these just because if I don't pare down this model, usually I go to sleep before the Dynamo query finishes. Okay, so what we're doing here, oh no, sorry, we're not doing this. We're doing it in Dynamo. Okay, pop this open. Okay, and what we're going to do here is look at this node, and actually I'm going to unfreeze this, unfreeze this, and I'm going to freeze this. And so what we have here is just like two workflows that we're comparing. And in one, we're grabbing two categories, and we're pulling out the solids that correspond to those elements, and then we're passing it into a straightforward geometry.intersectAll block. So we're taking all of the ducts and all of the walls, and intersecting them to find those that intersect each other. I mean, it's a very naive implementation of this sort of clash detection, but it'll serve our purposes. So we're going to do that, and we're going to, there's some timing stuff that'll compare that to implementing this with Retriever. And so inside of Dynamo, Retriever is very simple. It's exactly one node. And what this node does is take in one of these queries that we were looking at, one of these strings that you've assembled that describes exactly the condition of the elements that you want to isolate and any parameters that you want to extract, and gives you back the results. So I'm going to take this, and I'm going to unfreeze this node. Okay, and then I'm going to hit run. Here we are in manual mode. We're going to see how long this takes to run. Okay, now what are the bets? 1 second, 5 seconds, 10 seconds, 20 seconds, a minute? I don't think it should take that long. Uh-oh.
I'll be happy to do that.
Yeah. Okay, so actually, here's what we can do while that's chugging. We can go straight to the results. We ran this ahead of time just so that we would. Oh, I know how long it'll take. It'll take 27 seconds. This is just a chart comparing the performance of native Dynamo, so that script that we had, and using join to perform the query. So the number of intersections is just the number of walls and the number of ducts, and the product of them. So comparing every wall to every duct results in the model we looked at about 36,000 possible intersections, which is a fairly large number of intersections, but not actually outlandish for a real project. If we bump that up, we increase the size of the project and we do the comparison. We didn't actually get the number from Dynamo, but joins time does increase from 1.6 seconds up to 6.3. But in both cases is much faster than using the native Dynamo approach. Let's see if that finished. Okay, did it run? Yeah, it did. Great. So we can zoom in. We can see the results of the timing here. Oh, can't zoom. What's going on? So the time that it took the join retriever block was the difference between these two things, which was about 1.1 seconds. Good Lord, I just want to move. Here we go. Here we go. If we come down here, we'll see the same results for the native Dynamo approach, which was about 30 seconds there. So it's just like significant difference, and I'm guessing everybody likes having 30-second breaks inserted into the middle of their workflows, right? So how do we make that happen? That's a good question. And this is where we think this is one of the strengths of the query language approach to describing your models and extracting models from this. And when you encapsulate everything that you want from the model into a single query, there's a lot of optimization that can be done to make the execution of it a lot faster than doing it piecemeal, sort of one query or one element at a time. So here we have how performance looks without Retriever. We have Dynamo over in this world, and we have the Revit API, over here, and the Revit database sitting behind it somewhere. And every call into the Revit API is slow. The Revit API is a little clunky, but it's been shaping up a lot in the last few years. But it has a different memory model. And so every time you go get something from Revit, it has to be translated back into Dynamo. And so in the naive Dynamo implementation that we looked at, we say, okay, go get all the elements of this category, and you go over to Revit, and Revit gives you these back, and you unpack them and say, okay, now for each of these, go get me the geometry for this element, and I'm going to get this geometry back. And you say, okay, Revit, I know you know how to intersect geometry, or maybe this is a native Dynamo library. Here's like each of these pieces of geometry. Like, please tell me whether or not they intersect. And it's that back and forth that really kills performance. So with Retriever, things look a little bit different. So this workflow using Retriever, the first thing that happens is that you group together multiple Dynamo operations into that query string. So you're able to describe in one place, like, the types of elements that you want and the relationships that you want them to have, just in that one query. Then you hand that to Retriever, so you sort of, whisper the instructions to the dog, I guess. Retriever is able to analyze the query and optimize Revit API usage. So because it knows everything about what you're asking for, it can look at it and say, like, well, maybe I don't need all of that geometry. Maybe I can, group these things and figure out a faster way to iterate over them so I don't have to do all of the comparisons. Maybe there are ways to reorder the operation so that I find, a small group of things and iterate over it rather than iterating over a very long list. And maybe there are parts of the Revit API that are faster than other parts that I can sort of do first to help me in my search. And this is a straightforward, it's a common database implementation technique to sort of query planning, and we're really excited to bring, sort of one of the big exciting things that computer science has done into the Revit world. So Join analyzes it, is able to execute it with fewer Revit API calls, and then pass the results back to Dynamo as normal. And the result is that there are many fewer interactions with the Revit API, which leads to faster performance overall, both for simple naive cases, such as like intersect every duct with every wall, and for the more complex cases that we looked at, such as the building code example. Any questions on the implementation side? You guys could all go implement this now, right? Great. Okay, so the last example we have that I was going to bring up is trying to figure out whether or not a dog can solve a maze. Now, let me pull this up. Yeah, okay, so here we have our maze. It's a bunch of rooms, with walls and doors. It's a pretty straightforward maze. And the question is, can we come up with a retriever query that actually solves this? This is like a little bit complicated, right? Like, how do I ask for something that goes from one thing to another when all I can get is properties of particular elements? So we're going to ask for a pass between rooms. And for this, we actually have to inject. So this is sort of, you can imagine this as a way to inject different parameters or extensions to this. Where we're going to go in, we're going to select a room. Select the room. I'm going to take the start ID. I'm just going to assign that ID. And then similarly, I'm going to go find, the end of this maze, the other end of this, as I said, Join does fantastic architecture. The end room. And I'm going to assign that ID. So now I've actually taken this general query and I've specialized it to the particular model that I'm working with. I'm going to say, okay, is there a path between these two things? And it turns out the query to answer this is not actually that complicated. It's sort of 20 lines, 20 short lines of code. It rests on the idea of recursion and relationships between these adjacent spaces. But we can use this if we run this query to isolate a path through the maze that gets us from the start to the end. So I know a lot of things that, there are a lot of complicated things that need to be checked in building models, especially in things like healthcare. So you have, questions about access or fire escape, or, you're trying to do things around asserting that, nursing stations are optimized in their placement relative to patient rooms, that doctors spend time with patients rather than, walking between patient rooms, as good as the exercise may be for them. And so those sorts of, let me rerun that. Complex relationships are exactly the sort of thing that Retriever is designed for. You can encode those very complex things into these sorts of queries, and then you can evaluate them either to check rules on your models or to as part of some sort of QA step. Yeah, that's the maze. The dog can solve the maze. Yeah, so in that query, it just returns one, but you can get those paths back as a list, actually. Let's go.
What was that specific query? What was it actually?
Oh, so this specific query is taking the ways that you can go out from the start and the ways that you can go into the end and finding the path that combines those two. So you have the fan out from the, so this is a very simplistic example, but you have the fan out from the start, that's sort of all of the paths out from there, and you have the fan in to the end. And then you say, okay, I want to select all of the rooms that are on a path from the start and are on a path to the end. Yeah.
So in this particular example, I'm assuming there's only one possible.
Oh yeah, yeah.
What if there were more, like multiple possible paths?
Uh-huh.
Still function that way?
Yeah, that's a really good question. So maybe, the way that this one is constructed, there's you would just select all of those rooms. There's another query that you can write that's a little bit longer that will give you back a list of all of the paths. So it can tell you all of the paths from point A to point B.
And then you can add like an optimization query for like the shortest.
Yeah, exactly. Yeah, and you could order them by some metric. You could, I mean, so like these are like we saw earlier about like filtering things by sizes and so forth. So you could do things like find paths that, like if you're trying to worry about like moving equipment or something, like find paths that only go through doorways of certain sizes or along sort of circulation spaces with certain dimensions. And you can insert that into the criteria as it runs. Yeah.
One dumb question that I don't know if you covered it. And in terms of naming each of these queries in that drop down list at the top,
yeah.
how do you actually sort of, once you've written this, save that as that?
Oh, that's a really good question. So this is where I caveat this by saying this is totally like pre-beta software, but this is just text, and so you can save it out to disk, and you can populate this drop-down list just by indexing a file or just by indexing a folder on your hard drive. Yeah, so they're text. So I don't know if you're using some version control system and are super fancy, you can put them in there, but then it's just files on your hard drive, and you can share them on a network drive and share them between the firm or yeah, so wherever you want. Yeah.
Are there any plans to make this accessible to another plugin?
There aren't, but that doesn't mean there can't be. Yeah, we didn't have any plans. I mean, we do have the Dynamo API. That's it's not sort of the full API, but you can pass in queries and you can get the results out. So this is something that we want to release to the community to sort of give back for all the good work that Dynamo users and the Dynamo developers have done. So we're going to give this away, give it put it out in January. Later on in the year, we'll be releasing some of the stuff that we saw in GIF form a little bit earlier. Yeah. So you can build on it in Dynamo, or if anyone is really excited about a C# API, come talk to me. Yeah. Any other questions on the maze? Yeah.
The script is recently one that.
We're still working on a name for the language. We're thinking about BQL or Buckle for a building query language, but it's yeah, it's based on a well-known language called Datalog. Yeah, so we've got some examples here, and it's very straightforward to learn from examples. I don't want to say it's like too straightforward. It's definitely a new programming language that you have to learn. But the good news is, like, this is the entire language. There's nothing there that you can't see. There's no worries about sort of like keeping track of variable names or name spacing or anything like that. It's very, very simple. There's not a lot of language constructs. Yeah.
So you guys developed this language?
Yeah. This was all us.
And is there so for some people learn this the structure of it? Is there only by example right now?
Yeah, I mean, I'd be really curious to hear if anybody has preferences on how they'd like to learn it. We had been thinking sort of well-commented examples was a good way to start, just because you can run them on your models and you can sort of interact with it. But if people, is it like we did like a show of hands for like people that prefer like written documentation versus like video webinars, like how many hands go up for like written documentation? Oh wow, okay, and like video. Okay, and examples, just like shitloads of examples. All right, great, okay, great. Yeah, okay. All of the above, right? Just like every way you can get it, and you probably want the like the machine that just like whispers it while you're sleeping, right? Like so you just like it comes in the side. Yeah, yeah. We could send a dog to your house to sit there and look happy, I guess. Yeah, yeah, great. All of the above. Yeah. So yes, the dog can solve the maze. Where to from here? So we're going to be releasing this in beta form in January. We're signing up beta people. It's a beta just because we want to be able to provide like a very high level of support while it's being rolled out. But if anyone's interested in participating in a beta, we'd love to talk. Hand me a card or shoot me an email. My address is up there. Or find us online. Or yeah, please do reach out. And next spring. Some of the stuff that we saw a little bit earlier is going to start to drop either in Retriever or in another tool where we'll be able to, once you find the things, like, can you actually do stuff with it? Right now, Retriever just finds it, but we'll be releasing functionality that allows you to update, modify, or create Revit elements based on these queries. That's a good question. I don't know if we thought through the naming scheme. Like, what's a dog that builds things? Oh, sorry? Yeah. The shepherd, like keeping the model in line, I don't know. Yeah, so yeah, more stuff will drop in the spring, and this will be out in January. Yeah, Retriever, fast and flexible queries for model QA/QC. So finding data that's bogus or data that needs updating, building code, and maybe any custom rule checking, whether you're drawing these rules from the IBC or from some project-specific requirements that have been developed. Retriever can handle them, as well as analysis to drive computational workflows exposed inside of Dynamo. So if there's particular conditions where you want to trigger scripts on, you can use Retriever to drive those and to extract the necessary parameters. Yeah, thanks. That's what I got. I'm happy to stay and take all sorts of questions, but I do want to emphasize Louis after this at 55 Stevenson Street, and happy holidays. Yeah, great. Are there yeah, are there any other questions? Yeah.
Is it currently available?
No, but it can be really soon if you want to use it.
Is that going to be a package?
We'll release the Dynamo as a package, and there will probably be a separate installer for the Revit plugin. Yeah.
Just going back to the UI, is there any indication that if you have an idea of what you want to do, what you want to query, and you run the query and it doesn't perform the way you want it to, is there an indication like the text highlights or anything, that you're writing it wrong? Yeah.
That's a really good question. There's sort of two sides to that. One side is like, if I typo, like what happens and how do I know that I typoed? So we can provide pretty good tools for that in terms of both. I can't demo them right now. That's sort of what we're getting ready before we give the tool away. Both in terms of preventing that by providing autocomplete. So we can, we haven't built this yet, so take it with a grain of salt. But like if we're in here. The language is really simple, so Retriever can look at this and say, oh, you're doing a category, you're extracting the category, like here, I should give you a drop down of all the categories in the project. So you don't even have to type it, you just click it. So that's one side. And then on the flip side, we can check the program and sort of, I don't know if you've done any C# inside of Visual Studio or anything like that. It's a great experience if you ever want to write C#. But it's able to provide feedback in terms of where things have gone wrong, or say like, oh, you've misnamed something here, or oh, this query won't work like you've expected, or like, oh, you have a category name there, but actually it's supposed to be a parameter value, that sort of thing. Yeah, and then on the other side is, the query's valid, but it doesn't give you back quite what you want, and just debugging it gives you back sort of the wrong thing. So we have a few ideas on how to give that feedback to users in sort of a helpful way, but we're very interested in helping brainstorm more ways to do that. Yeah.
there a way to batch the process with different files without opening, for example?
Yeah, not right now. But we'd love to hear some specific workflows. I mean, just like if we're going to build that, we want to build it in like the right way. I don't know if you have ideas around. Is it? Like, yeah. Yeah. So that's something. I mean, if nothing else, you could do it through Dynamo. You could automate that through Dynamo, just because it's a node that you can run and just like open them in turn and so forth. But yeah. Cool. Anything else? Oh yeah.
So I know Join is also working in something bigger in the future. Are you allowed to say what that is?
Yeah, I can say a little bit about what Join is going to be working on in the future. We've got a pretty exciting piece of computational design technology that allows us to, we think we can describe designs entirely with code, but not in a way where you have to write code to use it, in a way where you can still interact with tools in a way that's familiar and design-oriented and makes sense. So we think we can bring a lot of power to a lot of stuff that's going on while still providing like, you know, an intuitive interface and a direct editing interface on top of it. How's that for cryptic? Is that like, yeah, something with computers. Yeah. Cool, great. Oh, yeah.
So can you make sort of user interfaces like find data and corridors?
Yeah, we're thinking about the right way to do that. One thing is definitely just populating a lot of these examples, so you could search for the query and then hit go. But adding the sort of yeah. Yeah. Yeah, I don't know if we've thought of ways so like instead of having like a join retriever thing where you come in and like select, you know, I mean, this contains concrete, right? There would be a button up here that like just does it. Yeah, that's interesting. We hadn't considered that. But I can see how like then there's just fewer clicks to run sort of a common.
Well, you could go through the building.
Oh yeah. All bathrooms, I hear.
Yeah, 88 bathrooms.
Yeah. Yeah, that's interesting. We hadn't thought about having sort of individual queries exposed as buttons that way. Yeah, we'll look into that. Thanks. Cool. Anything else? Yeah. Yeah. This is the thing we haven't built. Oh, this is one of the things we got to get done before we release it. So you'll be able to save them out to the file system, and they're just on disk, and we can index them and, you know, search them to some extent, and you guys can share them and pass them around or share them across the firm. Yeah, like really simple, really open, right? It's not this doesn't get saved as like some proprietary file format that like, you know, we hold really tight. It's just, you know, it's out there. It's ready for everyone to use. Yeah.
How did you guys decide to write your own kind of query syntax instead of basing on something like simple for like SQL? Because I'm trying to wrap my head around the question mark.
Oh yeah.
And like, how did you decide what like that was the right approach, the syntax?
Yeah, that's a really good question. So the language is based. This language is based on another language called Datalog. That's like SQL's, you know, unloved little brother in a way, where SQL's really taken off, and Datalog's like 40 or 50 years old. Datalog has some very particular runtime characteristics. The language is at this interesting point where it's very expressive. I mean, it solves mazes, right? You can express like very complex things in it, but you can still, it's still amenable to like very serious analysis. Where like, if you give me a Datalog program, I can understand what it's going to do pretty well. But if you give me like a JavaScript program, like who knows what the hell it does? Like crashes Chrome, I don't know, never finishes. Like you know that you can do things around Datalog that are you can guarantee more. So we started with Datalog, and the syntax that's on top of it is a reflection of that. Yeah, so it's that, and we can provide a lot of examples. There may be ways to massage the syntax. I mean, I don't know, the like, right? Like, I mean, we're we're still thinking about things like this, but like, right now you would go get like the name parameter and like get name. But wouldn't it be nice if instead you just said like x.name? So there are things that we can do that way where we massage the syntax that don't sacrifice sort of the power of dialogue under the hood. Yeah, we're thinking about those things. I mean, if anybody wants to give feedback on that sort of thing, we'd love to hear it. Please.
I have a question about that particular example. Is the query, do you have to run it separately? You had like multiple floors. Do you have to run it separately for each floor? Will you run it, or can you do it?
Actually, it does it, in general, Retriever will do it for everything unless you limit it. So right now this would run for everything, but we could limit it by saying like, okay, only do this if it's on, level 1. And then you could limit it to a single floor if you wanted, but it'll run on the whole model unless you tell it not to.
Like if you wanted, yeah, okay.
Great. Cool. Great. Well, thanks everyone for coming. Yeah, I hope everyone. Wait, where's the slide? Louise, 55 Stevenson Street. I don't know how long. Probably leave in 15 or 20 minutes.
There's questions
great.
on the
Oh, sorry, that thing's.
chat. Doesn't look like. If any in the audience online has a question, do it now. All right. No question.
Cool. Great. Thank you all for coming.
All right, thank you.